So one more ligand we have, one more kind of ligand which is quite important, something called ambidentate ligand, students. Ambidentate ligands. Word ambidentate means it has two coordinating atoms in the ligand. Ligand possesses two coordinating atoms, but it will not be binding to the central metal ion by using both the coordinating atoms at once. It has a choice. It can use two coordinating atoms, two or more coordinating atoms will be there, that is, but it will bind using only one coordinating atom. That is what is called as ambidentate ligand. For example, you have NO2 minus. If at all they ask you what kind of ligand it is a monodentate ligand only, because it will make only one bond with the central metal ion, one coordination bond. But it has a choice now. Either it can employ nitrogen for making a bond with the central metal ion, or it can use its oxygen for binding with the central metal ion. That means it is ambi in nature. That is, it has choice either to establish bond using the oxygen or to establish bond using the nitrogen with the central metal ion. Such kind of ligand which has two or more coordinating atoms but binds using only one coordinating atom is what is called as ambidentate ligand. For example, NO2 minus is the example, SCN minus. Take a look here, either nitrogen can be employed or sulfur can be employed. As we know, sulfur has a lone pair of electrons. Right? So, it has a choice. Either it will make use of the sulfur sometime or it may make use of the nitrogen. That means this is also an ambidentate ligand. For example, Cn minus. What kind of ligand it is? Is it a monodentate ligand? Yes, it is a monodentate ligand because it makes only one bond with the central metal ion. But it is a ambidentate ligand too, because either carbon can be used for bonding with the central metal ion or nitrogen can also be employed. For example, CO, carbonyl ligand we have. Carbonyl also carbon having the lone pair. Either the carbon can be employed for bonding with the central metal ion or oxygen can be employed for bonding with the central metal ion, or it can establish bonding by using either carbon or oxygen. In this case, either carbon or nitrogen, either sulfur or nitrogen, either nitrogen or the oxygen. These are the prominent examples we have for the ambidentate ligand. That means ligand has two or more coordinating atoms, but it will make only one bond. It has a choice what kind of the coordinating atoms has to be made use. So accordingly the name of the complex will also be changed. So when we name the complex, we will come to know how to identify which the coordinating atoms is being used for binding with the central metal ion. This is about the ligands. So I'll repeat again, students, one thing which could be asked for the competitive examination here is, that is, they may ask you give an example, what is the monodentate ligand among the following is, or bidentate, tridentate, tetradentate, or they may ask you which of the following is an ambidentate ligand. All those things may be asked. Alongside, one more aspect need to be covered here, student. There is something like the chelating ligands. Chelating ligands. Chelating ligands means chelating ligands also they could ask students. Just to keep it in mind, I will not be going details into it right now. Okay, chelating ligands are the one which makes a chelate ring with the central metal ion. For example, don't you think that if I keep a metal ion here, don't you think that we made a 5-membered ring? 1, 2, 3, 4, 5, 6-membered ring has been made. Yes, we made a 6-membered ring here. Right? If you consider the ethylene diamide, if I keep a metal ion here, 1, 2, 3, 4, 5, 5-membered ring, don't we made it? Right? Here also if you keep a central metal ion, 1, 2, 3, 4, 4 and 5. That means 1, 2, 3, 4. So that means we made a 4-membered ring here. Right, 4-membered ring using the ligand. So polydentate ligands, it could be a bidentate ligand or a tridentate ligand or tetradentate ligand, or in other words, if the ligand is having ligand coordinates to the central metal ion using 2 or more coordinating atoms, such kind of ligands can make a ring. Can make a ring with the central metal ion like this. It can make a ring. If I keep a metal ion here, this ligand can make a ring. Such kinds of the rings are called as chelate rings. Such kinds of the rings are called as chelate rings. Chelate rings, or ligands are called as chelating ligands. So what are chelating ligands? Chelating ligands are actually one which makes chelate rings with the central metal ion. Or I can say all bidentate and the polydentate ligand. Bidentate and the polydentate ligands all are example for the chelating ligands, because all of this will be making a ring with the ring-like structure with the central metal ion. This is about the ligands. So could be asked one of the area where the question could be raised in the competitive examination. Which of the following is an ambidentate, which of the following is a polydentate, which of the following is a chelating ligand. All those things could be asked. Just keep it in mind. We'll slip over to the next aspect in the coordination compounds. That is, again we will take these coordination compounds, students, and we'll deal with some other properties which are significant for you,